it goes back to the fact that I have a few problems stored. I'm sure you noticed there are a few problems stored.
Just a few.
Just a few. So it's this one. Does that look better?
Yeah.
There we go.
Do you give out the same practice test?
What's that?
Do you give out the same practice test?
Year after year. What I try to do is kind of like a sliding window. Like, this is 2020, so I try to give out as many, like I try to kind of stage it so that the last test you give might be like the 2019, most recent kind of thing. And so I go back so many years so I can get a certain number. So it's always like a window that's moving forward in time. Does that make sense? Yeah. Okay. Part B. Let's make sure we got the video going here. Okay, one thing I want to try with all of you is ignore this problem for a minute. I want to see if I can get you to have a better understanding of what they are talking about whenever they talk about a differential equation. So I'd like you to think with me. I'm going to try and pay as many points as I can. Ignore the differential equation that they're giving because it's fairly complex. I want to have the same discussion with a much simpler differential equation in hopes that your understanding will become so much better you'll never have trouble with even complex problems. Okay? If I were to say to you, here's a differential equation. Okay, so that's a differential equation just like this is a differential equation. The only difference is the differential equation I'm giving you is rather simple compared to the one they're giving you. But the concepts don't change, they're the same. They say let y equal f of x be the particular solution to the differential equation. This right here is the differential equation. This is the differential equation. In the math world, they like to call those diffie-Qs. So anyway, people get tired of long words. So this thing called y, or f of x, is the particular solution to this differential equation. And this thing, y or f of x, goes through this point. Okay? I want to apply that same idea to this example. So this differential equation, right here, this differential equation also has a solution. Okay, here's what they mean by solution. Raise your hand and answer this question. Don't think too hard. What is the solution to the purple equation? Hands up. There we go. Abby?
X equals 4.
Okay, the solution to the purple equation is the value of x, which will make the equation true. How many knew it? 2 points. 3 for Abby. The same works over here in the blue. The solution to this differential equation is the value of y. That will make the equation true. That you have to just memorize. But that's what's meant by the solution to the differential equation. It's like saying to yourself over here in purple, I have some unknown thing. When I add 3 to that thing, I get 7. So the thing must be 4. That's the solution to the equation. The same is true over here in blue. D of something, dx, must equal 3x squared. The solution to that differential equation, the solution to this differential equation is the value that I can plug in here that will make the equation true. So raise your hand and tell me what goes here in order to make this a true equation. Hands up. You can do it. There we go. Wait for a few more. There we go. what goes inside the parentheses in order to make that a true equation. Let's go China. If I put an x cubed here, the derivative of x cubed is indeed 3x squared. How many saw it before she said it? Point 2 for China. We want to talk more about it. Therefore, you could write, just like we wrote here, we wrote x equal 4 is the solution to this equation. We can write over here in the blue that y equal x cubed is the solution to this differential equation. That's what's meant by finding the solution to the differential equation. Questions? However, it is actually more accurate to say that this is the solution. Because when I plug that y in, it will not matter what value c has, it will still make the equation true. Questions? Okay, this is what's known as the general solution of the differential equation. I've never seen them ask you to find a general solution. They always ask you to find the particular solution. So what they're saying up here is they say, go find the solution y. But the solution y will be a function of x. So we could have written this. The solution is f of x equals x cubed plus c. But that's still the general solution. We're supposed to find a solution that not only works with the differential equation, we're supposed to find a solution that also works for this condition. That's also supposed to work. So we're supposed to be able to take our solution, plug in an x value of 1, and our solution to the differential equation is supposed to give us a y value of 0. So when they say solve the differential equation, they're asking for two things to happen. One, find the value of y, which can be plugged into the differential equation to make the equation true, but also find the value of c that makes it so that this other condition works for this formula f that we're finding. You want me to talk more about what they're talking about? I just had way too many people ask me, like they can't see what this even means. And you have to know what that means so that you don't get fooled by what they ask. Please.
So the general solution is when that makes the dy over dx true, but then the specific or the particular solution when it makes the dy over dx true and it passes through the point.
2 points. You can't say it better. It's perfect. When they give you a differential equation, they're giving you a formula that really is a rate formula. It's a formula for calculating the tangent slope of another formula. This formula right here. This is the rate or tangent slope of f. And so when they say find the solution of the differential equation, they're saying, just like Maggie said, go find the formula f, which when you solve it, it'll look like y equals something. That's what we did. That you can plug into the differential equation to make that equation true. But this formula f is also required to meet this criteria here, that when we plug in a specific x, we get a specific y. So as Maggie said, this formula f has to meet both. 2 points for Maggie. Hands up, what value does c have to have? Hands up. What value must c have for all of this to work? There we go, Trias. -1. How many know it? 0.2 for Trias. So now you know in this simplified example that this formula f would have been x cubed subtract 1. That is the particular solution to this differential equation. The differential equation is the rate formula. The f of x that we found is the amount formula. That's all they're talking about. Please, Ariana.
How is this different than when you use like the sassy?
2 points. So does this discussion here, does this feel like it makes sense? Good. When we have to do the same thing to this, like we really should be thinking exactly the same way. Like the way we find the solution to this equation is really the same way we're going to find the solution to this equation. The only difference is this being much more complex requires that we have a more step-by-step approach.
Oh,
That's what sassy is for.
because that one has like a y in it, so you have to separate them.
Yes. So that's right here. On your golden notes, this box that we've referenced many times says when we are starting with a rate, that's what the differential equation is. It's a rate formula. And we're trying to find an amount when that rate formula has an output variable, which is what Ariana just noticed. There's an e to the y. You have to use the sassy method. Did that answer your question?
Yeah.
Okay, 2 points. Okay, anyone have questions as to what the big idea is? Like, anyone need me to talk more about the big idea? As always, the big idea is the most important. If you get the big idea down, it's not that hard to get the little steps. But you have to get the big idea first. Somebody in A, I think I told you this, B8 said they had their mom was talking to them and she was explaining that it's really the same idea as an old story. I've heard this before, I don't know if you have. It's a demonstration, I don't have it with me, but they take a jar like this, they take kind of some large rocks, you've seen this, and they fill the jar with large rocks. And then they take quite a large volume of sand and they add it to the jar as well, and it just comes out perfectly on the top. And the idea is that if you start with the big ideas, if you understand the big idea, then the little ideas will flow into place nicely. But if you do it the other way around, you're going to have a lot of trouble. And it's very accurate as far as calculus goes. If you're always focused on what are the steps, what are the steps, what are the steps, and you're like, I don't care about the big idea, you'll never get the rocks in there. Like you pour the sand in first, you can't get the rocks to go in. Like you have to do the big ideas first. But questions here, please.
So the rate would be in, like, so the rate of f(x) is the differential equation, and out of that, so like the amount would be the general solution.
Oh yes, let me say it back to you. You said it perfectly, Caitlin, 2 points. The formula they give you when they say, here's a differential equation, it's no different than them saying, here's the formula that can be used to calculate the rate of change or the tangent slope of another formula. Finding the solution to the differential equation means please do whatever's necessary to find this formula, which is the formula for the amount.
Okay.
As I said to Ariana, because this differential equation is complex, we're going to have to use the sassy method to do it. In the example we did on the board, the differential equation was simple. So we were able to do it without a process, without a method, just kind of thinking our way through it. The one they give us too complicated, we'll get lost if we don't have a method. So yeah. Awesome. So now we're going to do the method. So can I clear this? Cool. Let's make a copy X in case we need it. Waiting for the copy. Fastest. There we go. Not yet. No, it's got it. Okay, so sassy means we separate first. So we need all input variables on the left. Sorry, inputs on the right, outputs on the left. So I'm going to end up with this. 1L over e to the y dy must equal 3x squared subtract 6x multiplied by dx. Don't forget the parentheses. Questions? Give the name for me. I built my lesson. Questions to that? Anything? Okay. My next step is to anti-differentiate, but I do not have an antiderivative rule for 1 over e to the y. So I'm going to change that to this. Negatives cause trouble. If you write -1, it doesn't cause nearly as much trouble. Questions? So the next step is anti-differentiate. That's the A in SASE. This is a AX plus B version of the E rule. So the antiderivative will be 1 over the A, E raised to the AX plus B. You don't have to write plus 0. That's just me emphasizing the rule. Questions about anything? Okay, we have now found the general solution to the differential equation. It isn't rearranged so that it says y equal, but it still is the general solution. If you were to rearrange that light blue equation so it said y equal, you plug that equation back into the differential equation in place of the y here and here, and you would find that the equation is a true statement. Okay, it's like, again, they've given you a formula for finding the rate of change or tangent slope of some other formula. You're in the process of finding the other formula. You're finding the amount formula. Okay, next step, C in SASE is to constantate, which means we've got to find the constant. So we've got -1, e raised to the -1. The y value is supposed to be 0, when the x value is a +1. Questions? Okay, do the thinking, don't just watch. Hands up, what's the value of C? Figure it out. What value must C have? Right, so just like you said earlier, Maggie, we're looking for an equation that meets 2 criteria. One, the equation we're seeking has got to be able to plug into here in place of y and make this a true statement. It's also got to be an equation where we find this equation called f. We plug into this equation that we found in x of 0, you've got to find a y value of 1. So in my equation that I found, that's what I did. I replaced all y values with a value of 0, and I replaced all x values with a value of 1. 2 points. Questions? Please, Ariana.
I have a question from like kind of before. It's like when you took the E out, did you just use the power rule or not to use that, the E rule?
Oh, gotcha. So you're looking here.
Yeah.
No, good question. To find this antiderivative, 2 points for Ariana, I have to use this rule here. This one. Because I've got the antiderivative of e to the -1x plus 0. So that antiderivative is going to be 1 over the -1, e to the -1. You see it?
Yeah. I just didn't realize that you need to power have its own rule.
No worries. You're thinking over here, right?
Yeah.
Yeah, no, good question. No, you have to use the e version. Point. Back to here. Anybody else? Awesome. So, again, hands up. What's the value of C, Ken? What's the value of C? Let's go with Brooklyn. How many got it? 0.2 for Brooklyn. So, our particular solution is therefore the general solution with these correct value for C. So this equation here is going to become -1 e raised to the -1y must equal x cubed minus 3x squared plus 1. Please, one in.
On the test, if you do that where you started in line, you need to put an arrow to show that it's a continuation.
Yeah, it's totally fine. Most important thing is to always make sure you're keeping track of your equal sign. That prevents mistakes. It shows the grader you understand. But the grader also would understand that you've run out of room. And an arrow is just like, hey, follow this, please. Totally fine. 2 points. What I think the grader's not going to like is I have seen students, there's no equal sign anywhere. The whole thing is arrows. Yeah, don't do that. The grader wants to see you understand that these things are equal. So. Now I just need to get the y alone. So I'd multiply both sides by -1. The -1 would have to distribute. So you would end up with this. Questions to there? Cool. Now I use the rule that says if I take the natural log of both sides, the natural log of e to anything is just the anything. So that means I end up with -1y. Question? Last step would be to multiply both sides by a -1 to get our final result. So we find the equation for y that if we were to plug this equation into the differential equation would be a true statement. Also, as Maggie said, if we were to take this formula for y and call it f of x, and we plugged in for the x a value of 0, we would find that the value of f of 0 is indeed +1 as required. So it would meet both requirements to finding the solution. That's a really bad ending there. Like so. Question? Here's how points are awarded on this problem. 1 point for getting to here, separating the variables correctly. If you can find both antiderivatives correctly, you get 2 more points. Pretty sure if you foul up at that junction, you don't get any more points. Like you've got to get that far to get the rest. If you get that part correctly, you plug in the values to find the constant, and you find the constant, that's 2 more points. And then if you can get the y alone, that's the final and 6th point. 6 total points on that problem. Question? Yes, sassy is worth a lot. And it's not that bad if, my firm belief is, if the idea we talked about at the very beginning, this simple idea here of what is meant by a differential equation makes sense to you, then you won't have any trouble with all the problems that deal with, hey, here's a differential equation. Now do something with it. Sometimes they want you to find the solution, which we did. Sometimes they don't. They want you to do something else. But the key is understanding what is meant by a differential equation. Questions about any of those? Awesome, cool. We'll stop the video.